This is a data set of the price of cars in thousands of dollars and the odometer reading. We also have a column here for the color of the car. So what we want to do is find the relationship between price and odometer. If we just think about it, obviously the price does not determine the odometer. You can't say because a car costs $14,000, that means that the odometer should have a certain value. But it does make sense to say that the mileage on a car it helps determine the price. So what we're going to do is use the data analysis tool pack. So I went to data, then now over here is data analysis. And I've got a bunch of options. I'm going to select regression. Now I need to put in my values. Easiest way to do it is to come over here and do, I have a Mac, so it's Command Shift down arrow, and that will take to the bottom, and repeat that. That's my Y is my dependent variable, and my X is my independent variable. And I do have labels. Okay, so we can see it's these values going in column A from value 1 to value 101. We've got some different options here. We can turn on and off. Let's do line fit plot, and we'll hit OK. And this is going to open up a new sheet here. So this is my plot. Let's take a look at that real quick. So we can see our predicted price here and our actual price. So as the mileage increases, the value decreases. All right, so there are a couple of things that we care about here. The first is about the goodness of fit. So how well does this model work? And for that, we'll look at the R-squared value. That tells us the proportion of the variance that's explained by the model. All right, so how much of the variance in price can be explained by the odometer? And we can think of this as a percent, because the R-squared value is between 0 and 1. So we would say 64.8%. So just do that times 100, and then we can make it a percent. Well, silly. 64.8% of the variance is explained by the model. Great. Another thing we can do is to see, is this model any good? And to do that, we can look at the ANOVA. The F value here is telling us the likelihood that all of the coefficients here are equal to 0. This F value is very large, which means that it's unlikely that all these values are equal to 0. Right, so that's telling us this model is potentially useful. Now let's come down here. We've got an intercept that's showing us where we start and our odometer reading. This is the coefficient. We call this one beta naught, and this one's called beta 1. The way that we interpret this is a 1 unit increase in the odometer reading is associated with a 0.066 unit decrease in price. So it's a little difficult. These are in thousands. So for every additional 1,000 miles you drive, the price decreases by $66. That's what that's saying. The next part here is to look at the T-statistic. This is telling us if this is potentially useful. And it is. Right, we can tell these values are large. They're statistically significant, showing that this is not equal to 0. Finally, we have our range of our lower and upper range. So that is how we do a regression using data analysis tool pack.